I think we are live. So, hi everyone. Let's see if I can. Okay, I think. So, for uh, hi everyone, and welcome to day three. Like today is the third day. Now, just to quickly recapitulate on what the agenda is like for this. It's just that when you are going to practice for any interviews, right? You get a lot of problems, and it might be overwhelming, right? So you have to it's not that you have to prepare in the last 1 2 months, but you should be preparing much before that. So it's always better to have those problems solved. Now solving those problems, you have to regularly solve 1 2 3 problems every day, right? So that needs some habit to be developed. So that's why we are doing this series, to develop that habit within you, so that even after we end the series, you can like regularly solve 2 3 problems. You enjoy the process, and in that way you actually solve a lot of problems by before your interview arrives, right? So we have only chosen the problems that selectively for Amazon interviews. But again, like, these problems are not only asked in Amazon but also in other companies. So definitely it will help you like overall, right? So, and from today we'll be giving a lot of homework. So there are, if you like, if you want the problem statement, like the problem we are solving today, or what are the homework questions, you can find everything in the description. So make sure to check the description, and before the next class you should be done with all the homework questions that are added, right? There are around 4 problems that are given for homework. I'll be talking about those as well in brief, or I'll be showing you the questions like which ones to solve once the class ends, right? So from today there will be homework. So with that, let's start our class for the day. So the first question that we'll be solving, I'm just waiting, like, if someone else wants to join in. Let's wait for them. Okay. Anyways, without wasting much time, let's start with the first problem that we'll solve today. So today we'll be solving 2 problems, pretty simple problems. The first is find the middle element in a linked list, and the second is removing a loop from a linked list. I'm pretty sure that many of you have already done this. So in case if you have done this, it's not mandatory to stay here. Just you can take the homework questions and get them done, right? But in case you haven't done this, or you don't know what's the best way to do these things, then I would recommend you to stay here, because I'll be explaining all the logic, like how things are working and everything, right? So first problem that we'll solve here is uh, it's finding middle element in a linked list. So what it tells is you are given a single linked list of n nodes. The task is to find the middle of the linked list. So you have to find the middle element of the linked list. For example, if the linked list is 1 2 3 4 5, then what is the middle element? The middle element will be 3, right? Because there will be 2 elements on the right, 2 elements on the left, so it's the middle element. So you have to tell, hey, the middle element value is 3, right? So that's the question. Now if there are two middle elements, like when n is even, when the number of elements is even, there are two middle elements, right? Like, just assume there are 4 elements, 1 2 3 4. In that case, 2 and 3 are the two middle elements. In that case, you have to print the second middle element, right? So you have to print 3. So this is the question that is given to us. It's pretty simple. Like, I don't think there's anything difficult in um, like understanding this question. It's pretty straightforward. So you are given 1 2 3 4 5, the output should be 3. You are given 2 4 6 7 5 1. I think the size here is even, right? 1 2 3 1 2 3 6. Okay, so here the two middle elements are 6 and 7, so you have to print the second middle element, so which is 7. So 7 is the output for this. So this is the question. pretty straightforward. There's nothing much to like understand here. So let's actually understand how we can solve this in an optimal way technically. Meanwhile, if you have any questions, you can feel free to leave them in the chat. Curious, why is it not showing me live? I can see myself, but the video is showing me it's waiting. Yeah, it's showing me it's weird. Um, so if anyone is here in the chat, can you please type something in the chat? I'm not sure if I can, if I'm having access to the chat as well. Like, if anyone is here, can you please write something? I just see there is one waiting. I don't see like any live or something. What's wrong with YouTube? But yeah, something is okay. There are 18 watching now. I can see the watch count. Please write something in the chat so that I can read. Like I can understand that at least the chat is available to. I can access the chat at least. Okay. Okay. Yes. 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 Now I can see your chat. Thanks. Thanks for writing, guys. So let's actually continue. Okay, so we have to find the middle element, right? So it's pretty straightforward. There are multiple ways. One way is definitely like, let's say you have 1, 2, 3, 4, right? Uh, let's say you have 1, 1, 2, 3, 4, 5, right? How can we do this? How can we find the middle element? It's pretty simple actually. We can initially just by one loop we can find the length, right? We can find the length of this linked list. So we can start from the head, we can go one place at a time, and we can increase the length. So the length becomes 3 here, it will go here, it will become 4, and then it will come here, it will become 5, right? So we'll increase the length. So we get the length of the linked list like this. Once we get the length of the linked list, we just have to move by length by 2 places, right? So length by 2, yeah, length by 2 places, right? So length by 2 plus 1 to be more specific. So length by 2 plus 1, so 5 by 2 is 2, right? 5 by 2 is 2.5, that's 2, and plus 1 is 3, right? So we'll move by 3 places, and I think that that will work. That will also give you the second one. Like if it is odd, let's say if it is even, there are 4 elements. So in that case 2 and 3 are the middle elements, right? So length by 2 is 4 by 2 plus 1, that is equals to 3, right? So 3 is indeed the second middle. So you can definitely do like this, but again there are two iterations that are taking place, there are two loops that are taking place. So it's order of n, this complexity is order of n, and order of 1 space complexity, but again there are two loops taking place. So the interviewer might tell you, hey, can we do it in a single loop, right? So that will be a follow-up question, that hey, can we do it in a single loop? So let's understand how we can do this in a single loop, right? There's there is some lag, I agree, but the lag is because of YouTube. Like there's some lag between the live and the when I'm speaking and the live when it is getting streamed to you. So that will be there. But again, like I think there is some issue on with my YouTube. Like I still can't see my video or something. So there's some issue with my YouTube. Okay, now I can see. Cool. Uh, Anyways, let's continue with the optimal approach, right? The optimal approach is to use two pointers. One is the fast pointer, one is the slow pointer, right? So let's understand how we can do this. So 1, 2, 3, 4, 5. We have to find the middle element, right? So what we'll do is we'll take 2 pointers, fast and slow. So let's say fast pointer is this one and slow pointer, let's say, is this one, right? So the fast pointer will be moving by 2 places at a time. The slow pointer will be moving by 1 place at a time. So when the fast pointer will be reaching the end that is null, there is a null after this. So let's say there is a null after this. When the fast pointer reaches the end, the slow pointer will basically be at n by 2, right? Because the fast pointer is moving at 2 times the speed. So when the fast pointer reaches the end of the linked list, the slow pointer should have covered half of the linked list. So that's basically the idea. So let's understand how this is working. So let's say after in the first move, the fast pointer, the slow pointer moves by 1 place. The fast pointer will be moving by 2 places. So it will come here. In the second move, the slow pointer is moving by 1 place. The fast pointer will be moving by 2 places. So it will come here. Uh, in the next move, the fast pointer is already at the end. So first of all, we'll move the first pointer. So the fast pointer cannot make a move because it's already at the end. So we'll just end here and we'll tell 3 is the middle element, right? 3 is indeed the middle element because see the fast pointer has reached the end, right? So let's understand for even as well. For odd it is working. For even, let's see if it is working as well. So 1, 2, 3, 4, right? So we have the slow pointer, we have the fast pointer. So the fast pointer will be moving first. So it will move by 2 places. So the first pointer will be moving by 2 places. It will come here. The slow pointer will be moving by 1 place. Come here. The fast pointer will be moving by 2 places again. So it will directly come to null right now. It will directly come to null right now. The slow pointer will be moving by 1 place. So it's moving by 1 place. It will come here. Now it sees that we see that it has reached null. So we'll end the loop here as well. So in that case, see it has again reached the middle element, which is 3, right? So it will always work like because I think the idea is pretty intuitive. Like one of the pointers is moving at a 2x speed, 2 times speed, right? 2 times speed. One of the pointers is moving at a 2 times speed. So let's say it covers a distance of L. So x will be equals to L by 2, right? The second point, the first pointer or the slow pointer will cover a distance of L by 2. So that's how we can actually do it in a single loop. So it's a single loop solution. So let's move to the code for this. Let me know if you have any doubts. It's pretty simple problem. So head is here. What we'll do, we'll take 2 pointers. Node star, where is star? Slow pointer equals to head and node star equals to head, right? So while fast pointer not equals to null, and either it will be null or it will reach the last element, right? So fast for even it will reach a null, for odd it will reach the last element. So next not equals to null. So either one of them is true. Fast pointer equals to fast pointer of next, and slow pointer equals to, it will move by 1, right? 1 place at a time. So slow pointer of next. Now whatever is the whatever is present at slow pointer, return slow pointer of data. Right? Whatever is there at slow pointer will return slow pointer of data. So I think this should work. So let's compile and run this. Let me know if anyone has any doubts. It's pretty simple problem. I'm not like, that's why I'm not elaborating on this a lot, but yeah, like let me know if you have any doubts. Submit. Okay, so it has passed all the test cases. So this is working, right? So this is working. Anyone has any doubts with this approach? Why is this working? It is pretty simple, right? We are having 2 pointers. One pointer is moving at 2x speed. The second one is moving at a x speed. So when the second pointer reaches, first pointer reaches the end, the second pointer should have ideally covered n by 2, length by 2, right? So that's the idea that we have used. So let me know if anyone has any doubts with this. Otherwise, we'll move to the next problem. Anyone has any doubts with the previous one? Let me know. And others can read this problem. I think most of you already know about this problem, like how to remove a loop and clear. Great. Okay. So next problem is removing loop in a linked list. Now this is a pretty popular question that is asked in interviews, right? This is pretty popular, and yeah, like we'll see how we can do this optimally. So you're given a linked list of n nodes such that it may contain a loop. A loop here means that the last node of the linked list is connected to a node at position x. If the linked list does not have any loop, x equals to 0, right? So the last node of a linked list will be connected to some node if there is a loop, otherwise it will not be connected, right? So that will form a loop, right? For example, 1 3 4, the last node is connected back to 3, so there's a loop between 3 and 4. Our task is to remove the loop in the linked list if it is present, right? Removing the loop in the linked list if it is present. So that's our task. Okay. So expected is order of n, order of 1, right? So I think it's pretty clear, like what the question is. Like you are given a linked list, there might be a loop, that is the last node might be connected to certain node. If the loop is present, you have to remove the linked list. Otherwise, you have to remove the loop. Otherwise, you don't have to remove. Right. So, for example, 1 2 3 4, it is connected back to 1. So this is an entirely loop, right? So you have to remove, like 4 should be connected to null after that. So that's the question. Let's see how we can solve this, right? So there are multiple ways. There are many ways to solve this. The one way is definitely, like you can take a map, right? You can take a map. You can take a map. Map is for C++. If you're using Java, you can take a tree map or something like that. Of type node star, or you can take a set as well, right? You can take a set as well. Not needed. You don't have to take a map. You can just take a set, right? You can just take a set of node star, and you can store the values here, like the nodes that you have visited. Let's call it a visited set. So you can store all the nodes that you have visited here. Now if you're visiting a node again, then there is a loop, right? So it's like that you can definitely do. But again, like that will involve additional complexity of space as well as time, so we'll not go into this. There's a better solution. We'll look into that. So the solution that we'll use is Freud's cycle detection algorithm. What we are using here is Freud's cycle detection algorithm, right? First thing that we'll do is, we'll identify if a linked list has a cycle, right? Using this algorithm, and then after that we'll go into the removal step. So how do we identify if a linked list has a cycle? Freud's cycle detection algorithm tells that, again, similarly, we will have two pointers, a slow pointer and a fast pointer. Freud's cycle detection algorithm tells that if the two pointers meet again, right, if the two pointers meet again, then there is a cycle, otherwise there is no cycle. Why does this happen? Let's understand. 1 2 3, let's say 4 5 6, right, and 6 is connected back to 3, let's say. So this is a loop is present here. So initially, so both of them will start at the head, right? Both of the slow and the fast pointer will start at the head. Now the fast pointer, as the name suggests, it will do the same thing. It will move by 2x speed, two times two nodes at a time. Slow pointer will move at x speed, that is one node at a time, right? So the slow pointer moves by one node at a time. The fast pointer will be moving by two nodes at a time. So what is the relative velocity between the fast pointer and the slow pointer? The relative velocity between the fast pointer and the slow pointer is x, is 1, right? So they will, if there is no loop, they will never meet again. If there is no loop, they will never meet again, because the fast pointer will always be ahead of the slow pointer, right? Because there is a relative velocity between them. But if there is a loop, they will meet. Why they will meet, we'll understand that. So it comes here. Let's just like iterate for a few steps and see if it is meeting. So next step, it will come here, and the fast pointer will be going by 2 places at a time. So the fast pointer will be coming here, right? Next step, the slow pointer will be coming here, and the fast pointer will be going by 2 places at a time. So 6 and 3. So it will come at 3, right? Next step, they will be meeting, right? They will be meeting. The slow pointer comes at 5. The fast pointer will be also coming at 5 because it is moving at 2x speed coming here. Let's understand why they are meeting, right? Let's understand why they are meeting. So see, you can think of it in multiple ways. I'll try to give you 2 ways to think about it. So one way is, assume there is a loop, right? There is definitely a loop. We are saying that there is a loop, otherwise they will not meet. So there is a loop. There are two moving pointers, right? Two moving pointers, P1 and P2. Let's say P1 is here, P2 is here. Both are moving in the same direction. What is the relative velocity? The relative velocity is 1 unit. Relative velocity is 1 unit. What is the meaning of relative velocity? If P1 is kept fixed, if P1 is kept with respect to P1, P2 is moving towards the clockwise direction by 1 unit at a time, right? That means if we come in the frame of reference of P1, that is, if we are sitting, let's assume that we are sitting on top of P1, or we are fixing P1. If we are fixing P1, it will appear as if P2 is moving by 1 unit at a time. P2 is moving by 1 unit at a time. So it will definitely loop back and come to the position where P1 is, right? As it is moving 1 unit at a time only. So it will visit all the possible nodes that are there in the loop. So that's why they are meeting again. That's one of the way to think about it. If you are confused with respect to relative velocity and these things, let's think about it in another way, right? Because again, like, these are physics terms and it might be confusing. So let's think about it in another way. So we have a loop. We have a loop. The slow pointer is moving by 1 unit at a time in the clockwise direction. The fast pointer is moving by 2 units at a time in clockwise direction, right? So we are taking the direction as the clockwise direction, right? If you consider the other direction, that is other way around, like the distance between the slow pointer and the fast pointer, this distance, the distance between the slow pointer and the fast pointer, it is increasing by 1 unit at a time, because the fast pointer is moving by 2x speed, so it is increasing by 1 unit at a time. But if you consider the reverse distance means this distance, because it is a cycle, right? So there will be two ways you can reach a point. One is normally, one is in the other way around, right? So if you consider this reverse distance, reverse distance is actually decreasing 1 unit at a time, because the forward distance, this arc is increasing 1 unit at a time. This arc, this is increasing 1 unit at a time. So this arc, the second arc, will definitely be decreasing 1 unit at a time, right? That will be decreasing 1 unit at a time. So that is decreasing, so means it will decrease, it will become 10, 9, 8, 7. So it will always, as it is going 1 unit at a time, so it will always come down to 0, right? And when it comes down to 0, that means they are at the same point. They are at the same point, right? So that is basically why they are meeting. I hope that this is clear about like why these two pointers will meet. Is it clear with everyone, or should I explain again? Let me know, should I explain again on this? Like, is it clear with everyone, or should I explain again about why these two are meeting? Is it clear? Let me know in the chat if it's clear. Be clear. Awesome. Now we have we have established the fact that they will definitely meet, right? If there is a cycle, they will definitely meet. Now how can we come to the how can we come to the conclusion that how do we find the starting position of the loop, right? If we are able to find the starting position of this loop, we can definitely detect the ending position as well, right? So our task is now to detect the starting position of the loop, right? So let's actually do that. Let's detect the starting position of the loop. Six, I think there was six, right? Six was okay. So now what we'll do, we will keep one of the pointers here. Let's say we are keeping the fast pointer here only, right? The blue one. The second pointer will move it to the front. We'll move it to the front. Now what we'll do, we'll move both the pointers one unit at a time. So in the first move, the slope point or the this pointer will come here, and the second pointer will be coming here. After one move, this pointer will be coming here, and this pointer will be coming here. So see, they are meeting again at the starting position now. Now, why is this happening, right? Why is this happening? Let's understand that. Okay. So let's say this is the cycle. This is the initial part without cycle. And this is the starting position, right? This is the point where they are meeting. While during the cycle detection algorithm, this is the point where these two are meeting, right? So let's say this distance here is, let's call it M. This distance here is X. Let's call it X. This distance here, this one from here to the starting point is Y. Okay. We have these. Okay. What is the total distance traveled by the slope pointer? Assuming that the slope pointer is not making any revolution, it is directly coming here, we can definitely find it as a multiple of revolution, like it is making some revolutions and then coming, and the answer will remain the same, right? It will become a more general thing. But let's assume that it has not made any revolution. It is coming here, and after that it is coming here, and then they're meeting, right? So without making any revolution, it is meeting here. So what is the distance traveled by the slope pointer? Distance traveled by the slope pointer will be M plus X. Distance traveled by the slope pointer. What is the distance traveled by the fast pointer? The fast pointer has reached it fast, so it is definitely going to make one revolution and then it will be meeting, right? Because it has already reached it, so it doesn't make any sense that they will both meet without making any revolution. So it is definitely making a revolution and then it's coming here and meeting, right? So what is the distance traveled by the fast pointer? It is M plus X plus Y plus X, right? This is the distance traveled by the fast pointer, because it is coming here to this point. It is making a complete revolution and then coming X units more to meet the slow pointer, right? So they are meeting, right? Now the time is same. The time at which they are meeting is same. And the speed of this one, the fast pointer, is 2 times the speed of this pointer. So let's say this pointer speed is V. So distance by V is the time. The time will be same, is equals to 2V. So V cut out, will cut out V. So V is no longer here, right? So M plus X equals to M plus X plus Y plus X by 2. That means 2M plus X is equals to M plus 2X plus Y, or 2M plus 2X equals to M plus 2X plus Y. I think this will cut out, and M equals to Y. This brings us to this formula that M is equals to Y. M is equals to Y. If we had considered that the slow pointer was making some revolutions and then meeting, then it would have been some K M equals to something, like that would have been a multiple factor, nothing else, right? So that's different, but let's just keep it simple and clear. So M equals to Y, this is the rule. This is what we are getting, right, by equating the distance. M equals to Y. Now what we are doing is, the fast pointer is kept here only. The fast pointer is kept here. The slow pointer is kept here. Now both are moving at 1 unit at a time at the same speed. So when the slow pointer is traveling a distance of M, the fast pointer M will also travel a distance of M. this pointer will also travel a distance of m, but we see that m is equals to y, so it will actually travel a distance of y, that is it will also reach the starting point. So that's why they are again meeting at the starting point. This is the reason why they are again meeting at the starting point, right? So uh, just to explain again, right, just to explain again, in case it's not clear with anyone, just to explain again, we have this loop. Let's say this is m, this is the starting point of the loop, this is where they meet for the first time. Let's say this distance from here to this point p, let's call it a p point, is x. The distance from p to back to the starting point, let's call it s, is y. So we saw that the slow pointer will be moving a total distance of m plus x, because it will come here and meet. The fast pointer will come here, it will make a revolution and then come, so it will be equals to m plus x plus y plus x by 2, because we are equating on the time, so it's 2 times the speed, right? Fast pointer has 2 times the speed, or it becomes 2m plus 2x is equals to m plus 2x plus y, or m is going there, so m becomes equals to y. So if we keep the slow pointer now here at the start, the fast pointer is kept at point p. Now when the slow pointer comes, both are moving at 1 unit at a time, so when the slow pointer comes to s, it travels a distance of m, so the fast pointer should also travel a distance of m like this, but m is equals to y, so it should travel a distance of y and thus come to the starting point. So they are again meeting at the starting point, right? So that's the idea, that's the idea about how you can detect the starting point. And once you've detected the starting point, you can definitely detect the ending point as well. You can either do it in the same loop, or you can just maintain have another loop where you start at this point and you go forward, as long as node of next not equals to starting point, right? You can just have a condition like this, so that will reach you to the end. So that's the logic. Let me know if it is not clear with anyone. So I'll just write the code for this. We'll do it in one loop only. We'll try not one loop as in I've written some code here. I'll just okay. So we have to remove the loop. So what we'll do first is we'll have the 2 pointers, node star slow pointer equals to head node star fast pointer equals to head. Now here we have to be a bit careful, right? Earlier we started off at head in the previous question, but here our condition will be while slow pointer not equals to fast pointer, right? So in that case, what we'll do is we'll start the slow pointer by making one move directly. So head of next, right? Head of next. And if slow pointer is equals to null, then we'll return that there is no loop, right? And fast pointer will also make one move directly, so head of next of next. So we are already done with the first move, and after that we'll start, right? So while fast pointer not equals to slow pointer, so if fast pointer equals to null, or fast pointer of next is equals to null, that means there is no loop. Not equals to null, is equals to null, then we'll return, then we will return, right? Because there's no loop. Otherwise fast pointer will move by 2 steps at a time. Fast pointer of next, and slow pointer will be slow pointer of next. Slow pointer equals to slow pointer of next. So both of them has reached, like they will basically meet after that, right? So now next part is we'll move the slow pointer back to head. Slow pointer will move back to head, and here what we'll do is we'll maintain a previous node as well, node start previous. Now we'll see if the meeting point if the yeah, slow pointer is next, that's fine. Okay, now we'll see here somehow if the fast pointer, if they're meeting at the head itself. So if somehow the first fast pointer is equals to head, in that case we just have to find the last node of the linked list. So what we'll do is while, so previous, let's keep it at fast pointer for now. So previous is fast pointer. So while previous equals to no head dot next, so previous equals to head of next, and while previous of next not equals to head, so not equals to head, we'll do previous equals to previous of next, and we'll return previous of data, right? Sorry, we'll make previous of not return, we'll make previous of next equals to null. We are reaching the last node, so we'll make the previous of next equals to null and we'll return. Okay, now if it is not equals to that, then we will go with the normal condition, that is while again slow pointer not equals to fast pointer, slow pointer not equals to fast pointer, previous equals so slow pointer equals to slow pointer of next, and previous equals to fast pointer. So previous is a previous node to fast pointer, right? So we will update it to fast pointer, and while we move the fast pointer one step ahead. So fast pointer equals to fast pointer of next, fast pointer. So finally we'll remove, so previous will be the last node because fast pointer will be the starting of the loop. So previous of next will be equals to null, and that should remove. So let's run this. Working, so let's submit. Let me know if you have any questions on this. Anyone has any doubts with how to do this, or how have I done the code? I think the logic should be clear, but anyone has any doubts with the code? Anyone has any doubt with the code, you can definitely take a look. uh, this part is simple, right? This entire part up to here is just cycle detection, Floyd cycle detection. This part is also cycle detection, only with one modification, that previous we are maintaining a previous pointer as well, just to maintain, like when fast pointer reaches the start of the linked list, the previous the start of the loop, the previous should maintain the last point of the loop, right? So for that reason, and this was a different condition when the fast pointer is indeed head, right? So in that case there would be some issue. So like they would meet instantly. Like if you see this loop, we are moving slow pointer to head. Now fast pointer is equals to head itself. So like it would just meet then and there. So that would cause problem. Uh, Please explain block 95. Sure, I'll do that. So what I'm doing here is let me explain the case. Like why have I done this, right? So let's say we have something like this. It might not be a valid meeting point, but let's just assume that it is, right? So let's say it is like this, and the slow pointer and the fast pointer are both at head. Okay, the slow pointer and the fast pointer will be are both pointing to the head, right? They're both pointing to the head. Now see, what is the condition here? We are making the slow pointer point to the head. Like the idea was what? The idea was that this is the cycle, will move the slow pointer to the head, the fast pointer will stay here, and it will then travel this distance while this will travel this distance, and they will meet at the starting of the loop, right? But again they have met at the head itself. So they have met at the head itself. So in that case previous now previous is also pointing to fast pointer. So this condition, if you just remove this one, right, if you just remove this one, slow pointer not equals to fast pointer, both are pointing to head, so this will be false. Sorry, this will yeah, this will be false in the first iteration only. So the previous of next, that is what is previous pointing to, now previous is also pointing to head, so heads next will be set to null. So that's why what we did here is we had taken this condition separately. We are saying that for this, we'll just find the last element of this linked list. So what we are doing previous equals to head of next, right? Previous equals to head of next. So previous equals to head of next means what? It will start from here and it will go while previous of next not equals to head. So it will come here, and now previous of next is equals to head. So it will reach this point, previous will reach this point, and it will do what? Previous of next equals to null. So it will make this null, next equals to null, and it will remove this, right? It will remove this. So that's how this entire block is working. It is only when the fast pointer is equals to head, because then this will actually give a wrong result, right? This will give a wrong result. uh yeah, tell your question. Like if you have any doubts, tell your question. In case it is related to the proof how it is meeting, I have explained that properly. You can just rewatch. If you have any question with the code, you can let me know, like what's your issue. And how did I approach this logic? You have to know this logic. I don't think that it is like really possible to like maybe it's possible for some, but again, like I knew this, that's why I'm able to do this. So that's why like you have to know a few things to be able to solve problems, right? Mohammed, I think you have missed. I already explained that. Okay, let me just explain again. Uh, the idea being that I've just explained. You can just rewatch again. Like I've explained there properly, but just to recapitulate in a quick way, the idea is that this is the cycle, right? This is your pointer. So this is the slow pointer. This is the fast pointer, right? Now, idea is that when they enter the cycle, right? When they enter the cycle, uh, just let's think about the cycle. What happens when they enter the cycle? So they are entering the cycle. Let's say the slow pointer is here, the fast pointer is here, right? The slow pointer is here, the fast pointer is here. Now there are many ways to think about it, but let's think in a simple way, right? Just consider like this is moving by 2x speed, this is moving by 2x speed, this is moving by x speed, right? So this distance that we have, this is increasing, right? Like just assume that you have you are two friends, right? One is moving 2 times ahead of you, so your distance between the two of you will increase by 1 unit at every point. So this distance between them is increasing. Now as it is a cycle, this distance is increasing. That means this distance will be decreasing. This distance will be decreasing by 1 unit every after every move, right? So this distance is decreasing. What does this mean? There's the upper limit, right? That let's say this distance is x, so we are decreasing 1 unit from x every time. Let's say x is 10, so it will become 10, 9, 8, 7. Eventually it will become 0. 0 means what? They're at the same point, right? They're at the same point. So that's why they're meeting again. Does it make sense? Just to give an example here, let's say the right now the distance between them, the slow pointer is here, fast pointer is here. The distance between them is 5. The slow point, now the fast pointer is moving by 2 units, right? It is moving by 2 units. The slow pointer is moving by 1 unit. So what is the distance between them now? The distance between them now has become 6. So it is increasing by 1 unit every time. The reverse distance will be decreasing. This distance will be decreasing. So if this was 10 earlier, it will become 9, 8. Like that, it will continue 7. Like that, eventually it will become 0. 0 means they will meet at their meeting. They're at the same point. I hope this is clear now. Is it clear? Let me know if it is clear. And meanwhile, I'll discuss about the homework problem. So the homework problem for today will be, today and tomorrow will be, first is delete. You can find everything in the description, so make sure you check the description out as well. So first is delete without head pointer. So you are given a pointer reference to node which has to be deleted. Of end nodes, the task is to delete the node. Pointer reference to head node is not given. So you are given a node, you are given a node and you have to delete that node, but you are not given the head node. So delete without head pointer. This is the first question. Second is intersection point in Y-shaped linked list. So you have a Y-shaped linked list, something like this. So you have two linked lists, Y-shaped, and you have to determine what is the intersection point. The second question. The third question is nth node from the end of a linked list, right? So you are given a linked list of L nodes and a number n. You have to determine what is the nth node from the end. So basically, second node from the end will be 8, right? From the end, the second node. Fourth is detect the loop in a linked list. We have already discussed this. It is simple Floyd's algo, but again, like this will practice your implementation. You can practice your implementation here, right? So this will be your fourth homework. So these 4 questions will be your homework. So make sure you do them before you are coming to the next class, right? So in the next class we'll be solving 2 more problems, similar 2 more problems, and we'll be giving more, right? So yep, let's so that's it for today, and thank you guys for joining in, and I'll see you in the next class. The next class is on Friday at the same time, 7:30. I'll see you there.